Okay, so in this question here, this is Unit 2, Activity 2, and you're asked to solve for n. But not just an easy solving for n, you also have to use combinations. In this case, I know it's combinations because there's a couple different forms for combinations, so I'm just going to show you a couple different ones just so you can remember these. So there's NCR, which is the same as having n over r, and then I believe that's it. So there may be one more, but the formulas are all the same, and just recognize the different representations for combinations. So when we go ahead and do something like this, you want to start by expanding or simplifying. So I would start by expanding one of the combinations. So if I take a look at the left side, if I take a look at this side, I'm going to expand my formula. So it's 4, keep the bracket. Here's the formula for combination. So you take n factorial, you do n minus 2 factorial times the 2 factorial. Okay? So that's the formula of n factorial over n minus r factorial times r factorial. Don't forget the factorials, that could change everything. So then I'm going to continue with the left side, and at this point, I have to recognize to either expand the n factorial or the n minus 2 factorial. So I'm going to take a look at what expanding n minus 2 factorial will do. So remember that when you're doing factorials, you always start with the term that's given. So I'm going to keep it in brackets just because there's 2 terms there. It's a binomial. After that, what you need to do is remember the rules of factorials. So that means we have to subtract from 1. And it's hard if you make mistakes with your integers at this point, because if you make a mistake right from the start, then it affects your answer at the end. So just remember to be careful with these operations. So n minus 2 minus 1. I can't do anything with the n, so I'm going to leave it there. But I do have like terms with these constants. And negative 2 minus 1 is negative 3. And then it just kind of keeps going like that. We keep subtracting 1 until we feel like we're done and you put a factorial. Expanding n minus 2 factorial will do absolutely nothing. We cannot expand this and continue and expect to get to n factorial. So knowing that this isn't going to do anything, we're going to try expanding n factorial. Same rules apply. So you start with the term that's given. So that's n. And then we're going to subtract 1. Well, this one's kind of tricky because when you subtract 1 from n, you can't really do anything other than write n minus 1. And if we keep going, we're going to subtract 1. You can see here that it brings me to n minus 2. And I can stop there if I put a factorial sign. So at that point, I know I want to expand n factorial rather than this one here, n minus 2 factorial, which will bring me to nothing. I can't simplify anything else. So I'm going to write that down. So n times n minus 1, and I'm going to stop at n minus 2 factorial because at the bottom I have an n minus 2 factorial. And if you only have multiplications going on between all operations, you can scratch them out. You can simplify them. So now we're left with 4 bracket n times n minus 1. There's no more factorial. It got simplified over 2 factorial. You can skip a few of these steps if you feel comfortable, but I'm just going to take it step by step to show you guys. At this point, you have to multiply. And again, these are exponent rules. So be very careful when you're doing this. It's a lot of grade 11, grade 10. If you get this wrong, again, it affects your end answer. So n times n means that you have an exponent of 1 on each. And when you multiply exponent or multiply bases that are the same, you have to add the exponents. So n times n, I'll write this down on the side. N times n is not 2n. You're not adding. Okay? N times n is equal to n squared. So I'm going to write that down. And then I'm going to continue to distribute the other n to negative 1. N times negative 1. You can't really do anything with them, so you just put them together. Negative 1n. 2 factorial is 2 times 1, which is just 2. Okay? So I'm left with 4 n squared minus n over 2. I'm going to keep going with the left side. At this point, again, since there's a multiplication between the 4 and this expression here, I can go ahead and simplify 4 divided by 2, which is 2. Okay. And from here, there's another multiplication. So 2 times n squared is just 2n squared. There's nothing you can do there. And 2 times negative n is negative 2n. So that's the left side. Scary enough. I know this takes a really long time. I'm just going to move all of my work here. Oops. Now we have to go ahead and work on the right side because we have to make sure that at some point we combine them. So what we're going to do here is go ahead and expand this right side. So equals, same idea here. You want to expand this with the combinations formula. So this equals n plus 2. Okay, the n plus 2 is the n. So n plus 2 factorial over, here's where it gets tricky. So remember the formula on the right side here, you have to do n minus r. Well, your n is a binomial, so it's n plus 2 minus 3. Now I need another bracket around here because that's the subtraction, but I want to make sure that the n plus 2 has a bracket as well. So there's a bunch of brackets happening here, and it's pretty confusing. I'm not done here. That's just the n minus r part. I also have to multiply by r factorial, which is 3 factorial. So if we keep going with this, we're going to simplify this little bracket first because it just looks messy. So you don't need to touch the numerator here. You can leave it as is. And n plus 2 minus 3 means that it's going to, the n's going to stay because there's no other n's in the bracket. And 2 minus 3 is actually negative 1. And this looks much better being simplified. Okay, so all I did was I took the like terms, which were the two constants. I did positive 2 minus 3. So that's all I did right here. Positive 2 minus 3 gives me negative 1. Maybe I'll highlight that, and that'll make it a little bit easier. So plus 2 minus 3 is negative 1, just so you know where that comes from. All right, so now we have to decide if we're going to expand n plus 2 factorial or n minus 1 factorial. Remember that you can always try this out on the side. So if I expand n plus 2 factorial first, since it's at the top, I'll just give it a try. Remember, I keep the same term, keep it in a bracket because it's a binomial, and then do minus 1. Well, n plus 2 minus 1, the n's not affected because there's no other n's, no other like terms there. But 2 minus 1 is 1, plus 1. I'm going to keep going with this. Well, plus 1 minus 1 is just n factorial. Oop, not n factorial. We don't want to stop there. Sorry, it's just n. I'm going to keep doing minus 1. So n minus 1. And I can notice here that there's an n minus 1 at the bottom. So that's where I want to stop. And if that's where I want to stop, you put your factorial. So knowing that, I'm going to expand my n plus 2, and I'm going to take that and put it right here. So n plus 2 minus 1 is n plus 1 times n minus 1, and I want to stop here, so I put my factorial. All of this over n minus 1 factorial over 3 factorial. And you can notice at this point that n minus 1 factorial is the same, so I could simplify them since there's all multiplications happening around here. So we can rewrite n plus 2 times n plus 1 times n, and this is where I'm going to start seeing a few mistakes if you're not careful. I usually start by expanding the one with one term, okay? So I'm going to do n times n squared, and I'm going to kind of ignore this n plus 2 for now. N times n squared, or sorry, n times n is n squared. I'm thinking of the answer. So n times n is n squared, not 2n. We're not adding, we're multiplying. 1 times n is 1n, or we can just rewrite it as n. 3 factorial is 3 times 2 times 1. I'll just go ahead and do that at the same time. So at this point, we have another multiplication, and this one's tougher because you've got a binomial times a binomial. And remember that when you have that, you have to follow the rules of FOIL. So first, n times n squared is n cubed. Outer, n times n is n squared. Now inner, 2 times n squared is 2n squared, and 2 times n is 2n. This may be something you want to rewind and review, because if you make a mistake here, again, it affects your outcome, your final answer. 3 times 2 is 6. 6 times 1 is 6. So I'm just doing the bottom part right here. At this point, I have to cancel out fractions. And I really just don't want that 6 at the bottom. And I can't just get rid of it. I can't just scratch it out. So to cancel out fractions, what you do is you want to get rid of the division by 6. So I'm going to multiply by 6. However, whatever I do to one side, I have to do to the other side. So if I do that, it'll just be a lot easier. So I'm just going to do it at the bottom here because we had simplified. So I multiplied 6 on both sides, which leaves my equation balanced. So I'm going to go ahead and do that. So 6 divided by 6 is 1. So this equals n cubed plus n squared plus 2n squared plus 2n. Now this created some more math work to be done on the left side. Just another multiplication. 6 times 2n squared is 12n squared. And 6 times negative 2n is negative 12n. There's a bit of math to be done on the right side. I know there's a lot of n's, but they're not all like terms. In order to be like terms, you need the same variable and the same exponent. So in this case, I only have 2 terms that are like terms. So 1n squared plus 2n squared is equal to 3n squared. Okay, now, when you're solving for n, you want to make sure that your equation is equal to 0. So if your equation is not equal to 0, it'll be much more difficult to solve. So that being said, you have to cancel out some of the terms. I'm just going to go ahead and cancel out the left side, just because my highest exponent is n to the power of 3, and I'd like to keep it positive. It really doesn't matter what you do, because you'll be using technology anyways. So let's just go ahead and cancel out positive 12n squared. I know it's positive because there's no sign in front of it. So I have to subtract 12n squared. And if I subtract 12n squared on the left side, I have to subtract 12n squared on the right side. I conveniently put it with the other 3n squared because those are like terms. To cancel out a negative 12n, you go plus 12n. Okay, that cancels out the left side, leaves me with nothing. And then this equals n cubed, 3n squared minus 12n squared is negative 9n squared. 2n plus 12n is 14n. And at this point, I'm ready to solve. You can use trial and error. Go ahead and try plugging in different answers for the n. For this equation to be satisfied, it needs to be equal to 0. So what I mean by that is if I try n equals 1, okay, for example, I'm going to try 1 cubed. I'm going to substitute all these n's with 1, and I'm just trying out this value. Doesn't mean it's going to work, but I'm just going to try it. I'm doing trial and error. 1 cubed is 1. 9 squared is, or 1 squared is 1 times 9 is 9, so negative 9 plus 14. 1 minus 9 is negative 8 plus 14. And negative 8 plus 14 is 6. And that actually does not equal. So n equals 1 is not a solution. Now, as you can recognize, this can take a really long time. And what if there are decimals? So what I suggest using is Desmos. So you're going to take this equation right here, okay? And you're going to type it into Desmos. So Desmos is just a free website. You just go to www.desmos.com, DESMOS. Okay, so I'll write that down after. And you type in, you can't type in any n's, so you just change your n's for x's. So x to the power of 3 minus, I have to look at the equation again, minus 9x squared, minus 9x squared. I'm using the buttons at the bottom to type all of this in. And then at the end, we have a plus 14x. So plus 14x. You'll notice that the curve shows up, and there are 3 values that will work. So n has 3 values in this case. N equals 0, n equals 2, and n equals 7. So that's what you go ahead and write here. You just go ahead and write n equals 0, n equals 2, and n equals 7. And I got this by using Desmos, which is www.desmos.com. n.desmos.com.